along the motto of CBmed combines is really standing for measurement of one or more samples of one of the same person with more core technologies, followed by a multi-omics data science approach. And this really combination of data sets gives us the possibility to really validate new biomarker discoveries. There are two main aspects of an advantage of the fusion approach. On the one hand is really combination of more data sets is kind of proving more the result that you're getting. So if you would combine that, or like compare that rather, with asking a direction for the main square in a city, and the more people you ask and they supposedly know the right answer, the more sure you can be that you're heading towards the right direction. So this is kind of like proving the question scientific we're looking at that is correct, or like more robust, so to say. The other aspect is if we choose the core technologies wisely, you can look really from the RNA level, see that there is an effect, and alongside that look at other pathways that are combining with that. And also, if that effect transfers really to the macromolecular level. So this really enables us to see where the effect starts, where it is acting, and when it stops. And oftentimes, when applying a fusion approach, there are even more wonderful things or scientific questions that arise after a fusion analysis. Fusion technology can be really applied to almost all areas and really wherever a scientific biological question comes into play. So whether that be analytical, descriptive, or even experimental setups. So really at any point where there is a too complex research question where looking at only one data set wouldn't provide a robust enough answer, this is where fusion technology would come into play. As in all the research questions, it is the quality of the result you get out is only as good as the data you put in. And by that, mainly focusing also on the pre-analytics and the quality of the pre-analytics, thereby also having a very strong focus on the robustness. So we have to assure that all the different types of samples we are acquiring, be that liquid or tissue, have a very strict and excellent pre-analytical process before they come into our labs. And that can also, like, oftentimes be quite challenging. So on the other hand, it is having highly specialized people looking at their data sets from the core technologies is really a challenge, but we're very happy to have these data scientists in-house. But also, when you have these kind of highly specific data sets, you mustn't forget about the holistic overview. So it's really important to have a very interdisciplinary team to get the best out of the data, because production of data is easy, I would say, but interpretation in the right way is the challenge. So for a fusion technology approach, all of our core labs can be used. That would be immunology, genomics and genetics, metabolomics, and digital pathology with multiple immunohistochemistry. They can be used all at once or in a modular fashion, depending on the scientific question. For some diseases, even stratification into groups that are not known so far is already a big leap forward. But also down the line, if we really have a holistic picture of one individual patient and with multiple layers of data, we can really improve treatment for the patient. So for every scientific questions, we are closely aligned with our scientific partners, being that, for instance, Joanneum Research, who is giving us technical support with the metabolomics measurements, or the Medical University of Graz and Vienna, who are providing the know-how for the scientific questions we are looking at. Also, we have industry partners in this project. Currently, we're working with Roche Austria and Roche Diagnostics, where we're developing using fusion for enriching a decision support system. Fusion is really able to unravel aspects and kind of look at blind spots that so far with the research question have not been answered. So it really comes into play where you kind of reach a dead end and where you need a multidimensional approach in order to have the answer you're looking for. So really anyone who is working in the field of personalized medicine can benefit from a fusion technology approach, because we are really looking at the whole biological systems with our multidimensional analysis, and by that you can really target and specific therapeutic approaches. So being closely connected to the medical universities in Austria, alongside with the biobank in Graz, which is the largest in Europe, and with our in-house data science know-how, we are really able to provide a one-stop solution for